In this example video, I'm going to show you how to solve a linear equation. So in a linear equation, what we want to ultimately get is x equals a number, or whatever the variable might be in your problem. We want to find what value it should take on to satisfy this equation. So here's the process for doing that. Each side of the equal sign, the left-hand side and the right-hand side, the first thing you want to do is simplify each side separately. So in example A, I see that I could do some distributing and probably combining like terms, so I'm going to do that on the left side. The right side looks like it's already simple, so I'll just carry that down. So again, first thing I'm going to do is distribute. Combine like terms. And basically what you want to do is simplify each side separately. And now that we've done that, I want to collect like terms on the same side. And remember, what you do to one side of the equation, you must do to the other. So I'm going to subtract 2x from both sides. Make sure you write it on both sides so that it's even. 2 equals 13x. And I need x to be by itself, no coefficient. This is multiplication, so I'll divide to undo that. So x is equal to 2 over 13, and that's my final answer. You can always check your answer by substituting this back into the equation for each variable x, and make sure that you end up getting a true statement like 4 equals 4 or something like that. Okay, so in this second example, part B, I'm going to use the exact same strategy. Simplify each side separately, then combine like terms, then finish off solving for x. So here on the right-hand side, I'm going to distribute. And there's no like terms to combine, so we're good there. I'm now going to collect like terms on the same side. So maybe I'll subtract 3x from both sides, leaving behind -7 equals -6. Okay, so at this point you might be going, wow, you royally messed up, didn't you? And no, I didn't, right? I distributed correctly. I performed this operation to both sides of the equation correctly. What happens here is if you get something that's false, like -7 equals -6, okay? First thing you should do, definitely go back and check your work and make sure you didn't make a minor mistake somewhere. And we didn't, we checked this work. So if I try solving an equation and it leads me to a false statement, what that tells me is that this equation has no solution. Or in other words, the solution set is the empty set. There are no solutions. In this last example here, part C, again, going to work the same strategy. Simplify each side of the equation separately before you start combining like terms across the equal sign. So I'm going to distribute over here. Carry down the left-hand side. I have some like terms to combine. And then I'll go ahead and start combining like terms. So maybe subtract 5x from both sides. So 12 equals 12. Hey, look at that. I got a true statement, but there's no x's in there. Okay, If this happens, again, first thing you should do is go back and check your work. Make sure you didn't make a minor mistake somewhere. But the problem with something like this is that there is no x anymore. There's nothing more I can do to solve for x. However, this time I got a true statement instead of a false statement. So you know what this means? This means no matter what I plug in for x, these two sides are always equal to each other. So in this case, we have a solution set that consists of all real numbers. Every single x is a viable answer. So to wrap this up, your possible solutions could be all real numbers, like in this instance, no solution, like in this instance, or a single answer. But the procedure was always the same. Simplify each side of the equation separately, then combine like terms by performing the same operation to both sides. Finish off solving for x, and of course you can always check your answer by plugging it back into the original and making sure that you get a true statement.